I'll show you a quick demo of GraphQL in action, right? And this is, I'm not going to take credit for this great demo. It was built by my colleague, Rob Zhu. I'll put the link. You can check it up. Anyone can use it. So essentially, there's a very famous Star Wars API. Has anyone used that before? It's called Swappy. Few of you all. Excellent. I think this is it. Is this the one? Yeah, it's called SWAPI. This is it, right? It's called, and I have to rely on conference Wi-Fi today, so wish me luck. But we'll get to it. So essentially, it's a good example of a good REST API, right? And it's a good example because it's very modular. It follows the format of REST. So if I had to ask you, and this, I'm just going to hotspot from my phone, just very quickly, because I don't trust conference Wi-Fi. I've done this too many times for it to fail on stage. So I bring my own Wi-Fi, basically, right? Yeah, so essentially, using this Star Wars REST API, if we had to find out this question, right? Fetch the names of all Star Wars characters that appear alongside Luke Skywalker. It isn't straightforward. Right? And I'll show you why, and I'll show you how the API is actually structured. Right? So this is the API, right? And maybe I think I've prettified it here. Yeah. So every character has an API, and you get this as a result. You can see in this result there are things like homeworld, right? Which again references the API again. There are things like films, which again references the same API. So if I needed the answer to something like this, fetch the names of all Star Wars characters that appeared with Luke Skywalker, I'll have to hit the Luke Skywalker API. I have to get all the films that Luke Skywalker featured in. I don't think it's updated to the new ones. Never mind. I'll have to go to those APIs, get the list of characters from all of it, do a bunch of data with it, and then actually print it out, right? And I've pre-written it here, so let's take a look. I'm doing it with REST right now. It took 132 milliseconds. If I do like a very quick inspect, right? This is the code. Sorry, I'm just going to refresh this. And you will actually see a whole bunch of, oh, I've lost. Yeah, and this is the code for, there we go, for the REST API itself. I've hard-coded it for the Luke character, but then I'm actually hitting all those different APIs. But it's actually making a whole bunch of calls, as you can see, right? I know why it's not showing up right now. Let me just do that again. Yeah, there we go. So there are like so many requests. So each of these APIs are actually hit because I've hit each of those REST APIs. Now, this isn't ideal in a real-world sort of scenario, and yes, these are all the characters that appear with Luke for the trivia fans here, because we invariably need just certain amounts of data, right? Right now, I don't need all of this data. I don't need whole homeworld. I don't need species. I don't need vehicles, starships. I don't need any of that. I just need the names of characters that appear with Luke. So if I have to be a little more efficient, why do I need to actually query all of this? And that's where GraphQL actually really shines, right? I'm going to fetch the same thing with GraphQL. It's just 15 milliseconds compared to 176 milliseconds in REST, and it's literally just one call, right? If you can see all the way here, it's just one call, and you can see what that call actually looks like, right? And what the response is. So there clearly is a very huge advantage and benefit of using GraphQL. So I'm going to dive straight into my presentation, and we'll get back to the demo as well. Again, this is a working demo. You can find it on github.com/RobZhu. That's my colleague, Robert Zhu. He has a bunch of great GraphQL demos. You should check it out. So what we did there essentially is, instead of making these separate calls like you would with a traditional REST API, we essentially made one query with GraphQL, which got exactly the things that we wanted, right? And as we move on to more modern applications, this is the sort of structure that we are seeing a lot of modern applications really implement. Yeah. So That's that. And I find it very useful to sort of define what GraphQL is and what it isn't. Right? So what GraphQL is, as you saw, there is like a very like a request response type format, right? The request was a GraphQL doc, essentially, right? And the response you got was a simple JSON. So in a way, it follows the request response paradigm. It is, in a way, a language specification as well, right? It follows a sort of query language where you know what you're querying, similar to SQL, where you didn't really need to know a lot about the table itself. As long as you knew how to like query, you could actually get that data. So it follows something similar there. It is a schema, and it is a domain-specific schema. I'll show you how this looks like. And it is also a server implementation. Right? So these are some of the things GraphQL is. It's also important to know what GraphQL is absolutely not, right? And I think people do get confused sometimes. So it is definitely not a client-side state management solution, right? There is a temptation to do that sometimes, to actually manage state using GraphQL, but that's something you don't want to do. You absolutely have to just use it to query things. It is not a solution for binary streams. It is not the Facebook Graph API. Right? It was developed in Facebook, or rather by Facebook, and now it's open source, community, all of that. But the Facebook Graph API is completely different. Right? So this is if you want to use and get data from Facebook and friends and photos and all of that. That's Facebook Graph API. And some things that I sometimes need to mention, that it's not limited to a specific database. It doesn't have to be only a particular database. You don't have to only use Node.js or JavaScript on the back end, or you don't have to use only like React on the front end, right? It's agnostic of all of these technologies. All right. And of course, it's not limited to only HTTP. So how does GraphQL actually work, and what can you do? Again, these are some of the basics. So there are 3 things you can do. You can do queries, you can do mutations, and you can do subscriptions. Right? So queries, as the name suggests, if you want to get some data, like earlier we got the characters that appeared with Luke Skywalker, blah, blah. You can do this with this sort of query. Right? And I'll tell you the structure. You start with the word query, that's important. You can give a name for the query. You don't have to, but you can. It's good practice to do so, especially when you're debugging. Check, hello? Can you hear me? Did the mic go off? Yeah? Sound technician person. I think the mic went off. Yeah? Yeah. Yeah. Okay. Yeah. I can maybe just talk loudly for a bit until this is figured. So, can you hear me at the back right now? Okay, excellent. Yeah, so here, I'm just typing the post with a particular argument. I want ID only one, right? So I'm not getting the other posts. Posts only with the ID one is what I'm getting. And what I want displayed is ID, title, author, and date, right? This is a query. At the same time, if you want to make any change, right? If you want to add a record or if you want to update a record, it's called mutation. Slightly weird word, but essentially the data is mutating or it's changing, so you do the exact same thing. So in this case, you're saying create post, and you're giving some arguments with ID, title, author, and date. The great thing about GraphQL, which REST APIs kind of struggle with, are actually things like subscriptions, right? Where you can actually subscribe and get real-time updates to some data. So in this case, we're doing an on create post. Oh, check. Hello, check. Yeah. Yeah, check, 1, 2. Check, 1, 2.
Fire alarm is active.
Oh, okay. I think we should be concerned. Yeah, I know. My code's fire.
Fire.
Yeah. I think that's a strange one where the fire alarm is active and the mics go off and there's no alarm. I'm a little concerned. Okay, check. Yeah. Check. Check, 1, 2, 1, 2.
Think you can just go on?
Yeah, I'll just go on. At some point, I'll suddenly be very loud, so apologies. Yeah, so like I said, where REST really struggles is things like live updates, right? I mean, there are different ways like MQTT and WebSockets, which we'll get to later. But with pure REST APIs, getting real-time updates is hard, but subscriptions sort of allow you to actually do that. The good thing about GraphQL, like I mentioned earlier, is suppose for this get post, all I need is ID and title. I can just specify exactly what I need. Right? I don't need the entire data to come and then for me to actually clean it up. I can specify exactly what I want. So in this case, I need ID and title. When I'm creating post, I just need to specify an ID and date, or I want to subscribe to just this, and that's it. Right? So I think that is really where GraphQL shines. Now, all of this is actually done when you're building queries. Oh, check. There we go. Okay. When you're actually building queries, but how do you actually look at it on the server side as well? So let's take a look at both. Right. So first, I'm going to look at. Okay. For a second, I thought the screen also stopped working. Right. So is anyone familiar with this tool? It's called GraphQL, whatever. So essentially, it's a tool you can use in the browser. You can connect to any GraphQL API, and you can just play around with it. So I'll show you how queries can actually be, you can actually make queries. The one great feature about GraphQL is it has this thing called introspection, where by its definition itself, it creates like a schema of the data and the data types. So in this case, I can just look at the schema here and the docs here. Right? You can see. Can you see it at the back? Should I? Is that good? Yes. Yeah. Okay. So this is it's created almost automatically thanks to that introspection feature of GraphQL. So you can see that these are the different types of queries available. Like it says people, persons, planets, all Star Wars still. We're still talking about Star Wars. If I click people, it says name, height, mass, all of that, right? And it's fairly easy to use, like, right? So in this case, I can actually just construct something from beginning. I can just say person, right? And look at the queries and say, okay, person, I want name and eye color, right? So in this case, let's actually run this and see what happens. It probably won't, right? So now it throws an error because if I'm mentioning a person, I need to give a name of a person as well. So I have to mention an argument here and give the name of a person. So in this case, again, we are going to go with Luke Skywalker this way. Yeah, and here I've actually said person named Luke Skywalker, so it's going to give me data all about Luke Skywalker. I'm specifying the name. In this case, you can see there, but also all the films Luke Skywalker has acted in, along with the characters in that movie, right? And if I want any other details, it's, again, very straightforward for me to do. So in this case, I've done person, name, film's character. So person, right, name is this, films is this, and with films, you can even get things like director and producer. So maybe let's try one of those. Right? So you can actually just see director is George Lucas of whichever film that is. But yeah, you can also get the earlier directors like Irvin Kershner and all of that. And literally all I have to do is just add that one small variable to the query. Now all of this is building the queries itself, right? So on the front end, if people want certain amounts of data, this is the queries that are being built. How do you actually figure this out on the back end? So what GraphQL uses is a system called resolvers. Right? And essentially, resolvers, like the name suggests, take these queries and get that data from the backend. So let me show you how the backend actually looks like. This is my schema, my GraphQL schema, and you can see I have resolvers for person, planet, film, vehicle, whatever. Right? This doesn't give us too much, so maybe let's take a look at planet resolver. That is in my resolvers.ts. And essentially, it's as simple as this. Right? I just am returning from an array, and that array reads from a flat file. So as you can see here, I'm returning people. Right? Let me see where that goes. This essentially just reads from simple JSON files, which list these things out. Right? So those resolvers are connected to some data sources, and these queries talk to the resolvers. Resolvers give you what you want. So that way, the GraphQL API is built from your front end to the back end. So that was how you would build the server. A question I get asked very often is, I've been doing REST for many years, right? REST APIs for many years. Our company has been doing REST for many years. How do you actually compare the two? And you're absolutely right. I think APIs sort of make the internet go around, and REST is it's this very stable thing. We've used it for so many years. And I'm sure that everyone here has used at least one of these frameworks, or whatever you want to call them, at some point of time. Right? At some point of time, you've used one of these. I want to ask you a question, though. How many of you can, over here, know what a REST API is? Yeah? Most of us, right? How many of y'all are confident that your definition of a REST API is the same as everyone else in the room? Because there is no standardized definition, right? By its very nature, there is no standardized definition of a REST API. If you read the original paper, I think it was in the early 2000s, there are architectural patterns and patterns for the API, but there's no formal definition of REST itself. So if I have to do a comparison between REST and GraphQL, the one thing is an actual shared definition, right? REST doesn't actually have, by its own, inception, it doesn't have a shared definition, whereas GraphQL does. So that means that with my knowledge of GraphQL, I can plug into any GraphQL-enabled data source and get data out of it, right? So it becomes easier for you to actually talk to a data source. Here are some other comparisons of REST and GraphQL. Very important that it's not a scorecard. Right? We're not saying, oh, GraphQL wins 5 versus 3 or something. These are just trade-offs, right? And based on your use case, there can be different trade-offs. I'll give you an example. Yeah, so let's talk about organization. The reason REST has been so widely used and is this bedrock of how we use the internet now is it's completely federated. Right? So if I'm reading Wikipedia, it's pulling data from IMDb, it's pulling data from some weather channel, which is in turn pulling data from somewhere else, and you can actually do that. Right? Whereas GraphQL is actually fairly centralized. Yeah? So there isn't one mental model which sort of works for the entire internet, and quite honestly, I don't think it's possible to actually do that because of the nature of GraphQL itself. Right? So again, think of that when you're actually building something out. Like I mentioned, this introspection, I think, is a very cool feature. Anyone here use Swagger on REST APIs? Swagger, yeah? So with REST APIs, you need to use something like Swagger to actually get that documentation out, right? Or have a huge docs team to write it out. Whereas with GraphQL, it can introspect, it can look upon itself and generate all of these things, so you don't actually have to do that. And of course, like I mentioned, I think where GraphQL shines is the real-time aspect itself. And a lot of what we're building, especially in consumer, business, whatever, is real-time now, right? With mobile and things. It might not have been as prominent in 2000, 2002. So GraphQL shines with the real-time. This talk, though, is about modernizing your API. And when it comes to a modern API, there are many challenges that actually people face. Anyone from a startup that's scaling to a very large organization. I've listed some of them here. There are many more, and I'm sure you'll come across these buzzwords in weekly emails and things. But you want things like efficiency, scalability, security, all of that, right? All of these buzzwords that you hear. The good thing is GraphQL actually addresses some of these very, very intentionally, and some things they don't address at all, right? Saying we're not going to worry about this, right? So I'll tackle a couple of them right now. I think the first one is the efficiency aspect, and I showed you a demo of how it works. With typical REST APIs, there is this huge fear of overfetching data, right? Which we just saw. Frequently, we get way too much data, not the most efficient. Not the most efficient way of network, especially in places with not great networks when you have conference Wi-Fis. So overfetching is a bit of a problem, but also underfetching. where you made this API call, you've got the data, but it's not enough and it's not what you actually wanted. So again, here's where GraphQL really shines. And networks do suck. I mean, we just saw the conference Wi-Fi here. We have all struggled with networks, right? And just to give you, and this data might, I don't know how recent it is, or it's a benchmark, right? Just take it as a comparative benchmark. But reading 1 MB from like an SSD is like, say, 400 milliseconds. But the same packet from US to EU or Europe is 150 milliseconds, right? And imagine this over larger and larger amounts of data and at scale. That's very slow. Yeah, so you really want to minimize and get exactly what data you wanted. And that's where GraphQL shines. Also, you can avoid things like overfetching and underfetching. Clients can actually declare all the data they need in a single network request. You saw that in the demo. There was one network request. I wanted all the characters that acted with Luke Skywalker. That's all I got, right? Nothing more, nothing less. And it reduces the application logic you have to actually write. With REST, I actually got all of that data. I had to do some application joins. Let me just quickly show you that code as well, where I made those API calls, right? If I do inspect, and I look at source, yeah, all of this is data massaging, right? Because I had to get the unique names there. But with REST, it was far more simple, where I just defined the query and then just hit the endpoint, and that was pretty much it. Yeah, so that is another advantage of GraphQL as well. Okay. We discussed this. And one thing that GraphQL specifically, again, addresses is type safety. Yeah, again, there is predictability because the type of query you're writing is the type of response that you get, right? That is the exact shape that you get. I don't need to know anything about the API to really get the data that I want. So I could plug into pretty much any data store that's GraphQL compliant and get that. This means that it works really well with things like native clients. You can actually generate code for GraphQL. So if you're doing something like Objective-C or Android or whatever, it'll actually generate code for it, and it works really well with native clients too. So there's that. Now comes the fancy question of, fine, all this is good. We have seen all of this. This is a cool demo. What about taking this into production, right? And that's where, it's not easy. And how do you actually take GraphQL into production? And when do you take GraphQL into production? So my favorite answer for most questions is it depends, because, well, it's when you don't know a definite answer, it's a good way to do that. But I'm going to give a very general answer here, right? And this is called the design stamina hypothesis. If you haven't read about this, you should check it out. It's a paper written many years ago by this guy named Martin Fowler. And essentially, the hypothesis was, when do you use any new technology, right? Not just GraphQL, not just React, whatever, but any new tech, when do you actually use it? So what he did was he plotted time and on the x-axis, and he plotted cumulative functionality on the y-axis, right? So over a period of time, your system's functionality, cumulative functionality, is going to increase, right? If you don't do anything, right? If you don't incorporate design of your system, this is the sort of curve that you typically see. In the beginning, it's fine, right? In the first part of your project, you can see it's almost like a 45 degrees. Your functionality is increasing, but as time progresses, it starts impeding your growth and your project, right? Because as your systems get bigger, you need design. You need system design, and that's going to stall at some point of time. Yeah. What if you did have good design? So systems with good design usually see this sort of curve, right? Where at the start, it can be a lot slower because you're spending time doing architecture, design, security, documentation, and all of that, which impedes your cumulative functionality. But as time goes on, good design always will win out. Yeah. So essentially, there is what is called a design payoff line, which is this intersection point, right? If you are at the stage that's maybe below this, maybe you don't have to move to GraphQL. Yeah, you're still like sort of experimenting, it's still proof of concept. I think it's okay because, well, it can be complex and it is an overhaul. But if you're building for that end part, that's when you can actually start deciding about moving to GraphQL or any other technology, right? So again, very, very interesting way of putting it in a framework. So do check it out because we are frequently faced with these discussions, right? Almost every day there's a new framework. Any JavaScript fans in the house? Yeah, there's a new framework. Everyone's like, this is the best framework, or you know how it goes, right? So use this mental model to sort of figure out when to actually adopt a new framework. Some do's and don'ts when putting GraphQL and modernizing your API. Do's, don't try and complete your schema up front. We've seen people try and fail with that because it can get very, very complex if you want to do it up front. And things change, requirements change, a lot of things change, so don't try and aim for that up front. Don't place business logic in your GraphQL layer, right? The GraphQL layer is for the querying and the resolving. Don't try and place business logic there. There's a separate layer where you can place business logic below the GraphQL layer. And don't try and replace your REST API in one push. This talk is not about REST is terrible or it's bad or whatever. REST is great. We've been using it for many years. It's proven. So don't try and do this overnight migration to GraphQL. Instead, again, start with education. Choose a solution that sort of fits the stack that you want to build. And always start with something simple, like a read-only query. And then you can layer in features like mutations. And eventually, when you have like a stabilized sort of system, you can expand your schema to add things like subscriptions, right? So again, it is a process, and recognizing it's a process is important. Now comes the AWS aspect of it, right? Again, in production, we typically don't have just the one data source, right? It's not like the one user and the one data source like in this neat little demo I showed you. We are talking about scale, right? Folks, I'm sure here work in banks, in huge corporations. You have so many different data sources, so you need something to sort of orchestrate how all of this data is moving. And AppSync is a scalable way to do that, right? It's completely serverless, so you're not managing the scale of AppSync. And again, all you have to do is work on that logic itself. You don't have to manually do it. So this is typically how any app looks, right? Where you have your end users here. Could be IoT, could be mobile, web, enterprise, whatever. All of them will, in a sort of centralized way, talk to AppSync. And AppSync is the one that talks to all your different data sources, right? And this takes care of all the synchronization, querying, resolving, all of that from all of these data sources. So that could be from a NoSQL database like DynamoDB to your caching, to any Lambda functions you might have, to any other HTTP APIs as well. So how does that look in real life? Well, let's take a look. Let's take a look actually using an example of an e-commerce store. So you have your API consumers here. These are your front-end clients, whatever. Via GraphQL and AppSync, they are going to access a bunch of data. But here's the thing, your data is spread across many different services, right? Your user profiles are on a NoSQL database, DynamoDB. Your orders are on Amazon API Gateway or any API gateway. Your inventory is processed via Lambda, and your pricing is on Aurora. Right, so this looks like a nightmare if you didn't have something here to actually talk to. Right? Imagine doing this on like REST APIs to each of them, because for one order, you'll have to get like a profile API using DynamoDB. You have to get pricing from here. This is an absolute nightmare to actually manage. Right? And with modern technology, we have to build in a modern way, and GraphQL and AppSync actually allows you to do that without having to worry about any of these things. Yeah, so all of this backend complexity is sort of reduced to like a single request and a single endpoint. So quickly show you how that actually works. You build your data model, your GraphQL schema, which I showed you, and you build your resolvers, your set of business logic, right? And AppSync is that layer in between all of this and your data sources itself. Again, this can get complex, like I said earlier. What if one data source needs some result from the previous data source? So, well, there are actually two types of resolvers you can run. Right? So the first one's called a unit resolver, where it's one resolver talking to one data source. It's in serial, all good. You can also run something called a pipeline resolver, right? Where it is actually a bunch of unit resolvers, one after the other. Say, for example, the first one, you need some data from your SQL database. So your resolver talks to that. It then puts the result in something called a stash. Think of it like as a temporary map. And then the second call goes to your NoSQL database. The third one maybe goes to Lambda. But all of this is handled via this pipeline of resolvers that you have actually built out. And again, AppSync takes care of a lot of that complexity for you. The good thing is there is auth and security built into AppSync, as with GraphQL. So you can actually get access from your users with any of these methods, right? So say, someone accesses that API via API key, someone does it via Amazon Cognito, and someone does it via AWS Identity Access and Management. So you have 3 different types of users, all of whom have to access the API, and all of them have different levels of access. Again, sounds like a nightmare to manage on your own, but AppSync makes it easier to do that as well. So assume Cognito is our default, and these two are not default. You can actually have multi-auth written into AppSync as well. So I don't know if this works. Yes. So assuming this is like an airline management thing, so we say type flight. These are the 3 security authorizations. So you have API key, you have Cognito user pool, which is default, and you have AWS IAM. So all of this, because Cognito is the default, all of this data is accessible to a user who's logged in via Cognito. Right? So everything from departure airport code to arrival city, all of this data is accessible. But you have users who are accessing it via API key. So in that case, you can specify what data those users with API key can access. In this case, we are saying they can access just these 2 pieces of data. Right? We also have a third one, which is AWS IAM, and we have mentioned some piece of data here in blue that users who are logged in via IAM can access. Right? So with this, whatever, 30, 20 lines of code, not even code, just, yeah, you can actually have multiple authorizations from different identity providers for your API. Right? And again, this is one of the ways you can actually modernize. So let's actually move on to something real-time. Right? We were talking about systems that access data stores. Like I said, GraphQL shines when it comes to real-time, and GraphQL has subscriptions. Right? So anyone used MQTT and WebSockets in the past before? Anyone? Yeah? So GraphQL has support for WebSockets. It used to support MQTT, but it stopped because the payload size is fairly small. With AppSync and GraphQL, you can actually get real-time subscriptions as well. So here are your users. You have a subscription to something called create order, and there is a secure WebSocket connection created from the user to AppSync. Again, AppSync is connected to all of these different data sources. Now, at scale, something like this is going to happen. So you have all of these different users, right? Say it's Amazon Prime Day, everyone's looking for the best deal. Everyone has a secure WebSocket channel from their device to AppSync. And let's assume, for simplicity, that we have just the one data source here, Amazon DynamoDB. So say someone makes some purchase or something, right? Someone's added some mutation. That goes from AppSync. AppSync then talks to DynamoDB to add an item in the database. Right? That is the single point of contact. It's speaking to that local that resolver here, which then puts it in DynamoDB. Now, all of these people need to know about this. Right? So all of that data can then be propagated, because remember, this is real time and it's a subscription. So all of these people now can see an updated version of that inventory. With AppSync, you can also choose to inform only the ones that need to be informed. So maybe just these 3 people need to know of this, right? Maybe there was just one item remaining. All of these people had bookmarked it. You want to tell them that it's out of sale now, right? So you can specify in that subscription whom to inform or whom to update with that data, right? You can actually do this even one-on-one. Like say it's a chat application, only one person needs an update. You can actually do that as well, right? So this is how it would work in real time with a subscription. Again, let's add more complexity. So you have users, you have AppSync, you have DynamoDB. What if there is some update from the backend, right? There's no update coming from here. There's some update from your backend systems here that needs to update in your database. Well, you can do that as well. Excuse me. Say you have something like AWS Lambda that updates a function, right? That can also be connected to AppSync with, again, a mutation. Again, goes through the exact same process of put item, resolver, updates the database, and then sends that update to everyone else who's subscribed to it. Yeah, exact same thing. And as you can see, it's gone back to everyone. Let's add more complexity. What if there is something that is called an out-of-band request, right? So this request has come to the DynamoDB table, but it's not come through AppSync. Remember, AppSync is the point of contact. Well, in this case, there's not much that AppSync can actually do, because this DynamoDB is being updated by something else. But we need to actually build for this as well. So how you can actually do this is use a DynamoDB stream to update a different Lambda function, which in turn then sends a mutation to AppSync. And then you can't actually go back here and resolve it again, because that would make it double. Right? We have already had an out-of-band request here. So there is something called a local resolver, which resolves that data to AppSync and then can actually send it out to everyone. So this way, everything is synchronized between DynamoDB, AppSync, and the user itself. The thing is, when we're building modern apps with modern APIs, these are frequently the sort of requirements that we come across. Right? And you have now all of these tools to actually just focus on your business logic. And all of this is sort of taken care of by services like AppSync and by frameworks like GraphQL. So again, if you're doing that, I highly recommend you check it out. Quick note, but AppSync, again, integrates with things like protection. So you can put the AWS Web Application Firewall, or if you have your own firewalls as well, around the API, so that it doesn't have access from people that you don't want access to. Observability, if you want to see how your API is working end-to-end, you can use X-Ray. Insights using CloudWatch, and also you can cache it using Amazon Elasticache. All right, that was pretty much it. I know I covered a lot today, but I sort of wanted to show a demo, talk a little bit about GraphQL, but also talk about the modernization aspects. If you're new to GraphQL, the actual GraphQL official site is great. They have a great community. I'd recommend, if you've not used AppSync, is to try the workshops. We have some, build like a web app in 30-minute type workshops. You'll find them here. A good way to sort of get used to AppSync, GraphQL, and so on. Oh, great. I have exactly 5 minutes if anyone has questions. Shoot, yes?
I was wondering how to implement GraphQL in an existing application
Uh-huh.
that uses REST and connects to a relational database system.
Yeah. So that's a question that we actually get asked frequently, right? And so the one way of looking at it is the technical way, but the very business way of looking at it is think of it as a process, right? And we frequently tell people to start migrating things like queries and stuff, something that's not as mission critical perhaps, into something like this, right? You can still have those data stores access via AppSync, and GraphQL can talk to them. And that's how we recommend people. There is no like magic, like click this button to turn a REST API into GraphQL, unfortunately, right? At least as far as I know.
Should I put some kind of proxy or plugin in front of my MySQL database or application server? What steps do I need to take?
Do you mean for your GraphQL to talk?
Yes, because I have, Call Fusion website.
Okay.
And it uses SQL queries
Mhm.
and queries a relational MySQL database. So I can start to rewrite queries, but the application server doesn't know how to handle those,
Right.
obviously. So what steps should I take in order for the application server to understand those GraphQL queries, because
Right.
those are clear.
Yeah.
I understand how those work, but
Right.
it needs to be processed.
Yeah, yeah. So in case you didn't hear, the question was there is an RDBMS database in the backend already uses it's a Cold Fusion website. You said, yeah. I've actually not done one of those, so I'd be interested if anyone here has actually built. I would, of course, one way of advising, and this is completely biased, but is to migrate to like a managed version like Aurora or something where you can actually use it. But I don't know if anyone's built a GraphQL database that talks to RDBMS. Has anyone done that? Yeah, I'd love to hear from you. Anybody? Okay, maybe I should look this up. It's a very specific thing. I'll look it up. I actually don't know, to be very honest. I haven't done one of those before, but yeah, it's a good question. I need to look that up. Okay, anyone else has any questions?
So it means you should have to start it from scratch.
Sorry, what's
If
that?
you want to use GraphQL
Yeah.
for this imaginary web application,
Mm-hmm.
the thing is start over, rebuild the application, or at least the backend, the data store,
Mm-hmm.
using GraphQL.
So I would check if AppSync actually works with, and maybe I can just check that now, if AppSync actually works with something like an RDBMS.
I'm not
Sync.
trying to RDBMS, I just want to use GraphQL.
But your database is thing, right?
I can
So
migrate that.
okay. So then, I mean, there you go. So that is one option. But let me check if AppSync. So Aurora serverless, for instance, integrates with AppSync. So that is one way of looking at it. So you could potentially do that. Again, with these things, my frequent answer is it depends, because there are so many different variables. But that could be a way to go, right? Migrate the database to Aurora, have AppSync talk to Aurora, and then build GraphQL that talks to AppSync. Cool. Yeah, thanks. I hope you learned something.